Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge, week 4. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other problems, whatever you like. Um, but also that I usually solve these live, so you get to see my thought process. If it's too slow for you, fast forward or watch another video, it's all good. Okay, so today's problem is determine if two strings are close. Two strings are close if you continue one by using operations. Swap two characters or transform one every occurrence of one character to another one and do the same for with another character. Okay, so you could swap, so that just positionally. So then, and you can do this infinite times. So that means that as soon as I see operation one, I know that I can just sort the string because that would be roughly optimal. Maybe there may be other nuances as well. Transform every and do the same with the other character. What does that mean? Turn A's to B's, B's to A. Okay, so this means that, and actually I take that back. It doesn't have to mean sort, but sorting is probably going to be common. But looking at operation 2, it seems like what I would do is put in a whatchamacallit, hash table. Okay. So basically, you just operation 2 swaps. So okay, let's start over. Operation 1 swaps the position so that yeah, the positions don't matter. So or rather, the characters don't matter. And then operation 2 makes it so that even the characters don't matter. In that only the character counts matter. So you could probably do a one-liner if you're really funky. So the way that I would do it is okay. So, and this is me trying to like competitive programming it. So you have a collection dot counter from word one, and then now here you could take the values of this and you can either sort it or put it in another hash table, but it's fine. So you can probably do something like return this as you go to the sorted collections dot counter words to dot value. Don't worry, I will I will explain this and also go over it in a little bit. Ooh, then word to oops. But this is what I would do in a contest or something like that. Okay, we need to. This is a. They need a button for me to do the test cases, so then I could do my videos quicker. But give me a second. This is the montage, and again, I will explain the entire problem again. Maybe I'm just showing off a little bit as well, because yeah, I think I explained it a couple of times, or maybe not a couple of times, but I explained it a little bit. So I think this is in theory maybe okay, but let's see. And I'll explain it more once it is correct, because if it's not correct, then that is just embarrassing. So let's see. Okay, so that looks good. Let's give it a submit. Ooh, wrong answer. Did I misunderstood this one? Oh, they have to. Okay, I did misunderstood this one. So you have to. So you have to swap two of them. So you can't just replace them. Okay. Wow, that didn't come up in all the test cases. That's actually surprising. Okay, so I am a little bit wrong on this one. So you get to see me make a fool of myself because I thought that you can convert all the U's to S and all the A's to X. But it seems like now that I read it a little bit more carefully, you can only map them back and forth. So, okay. So I think this is still true for the most part. It's just that you have to make sure that the set of the words are correct. So you just have to add someone like is equal to something like this. I actually don't know if this is true. In the sense that I actually don't remember if the set of a word gives you the set of characters. Let's kind of give it a C. If not, then we'll have to do something closer. So yeah, okay. Let's give it another submit then. Okay, cool. Yeah, so I had a misunderstanding, but still a one-liner. So we'll break it down. Don't worry. what is the complexity of this? Let's do the complexity first for a second, just because it'll be amusing. This doesn't look like it. This is actually linear time. Or if you want to call it that, alpha log alpha times linear, where alpha is the number of characters, or the size of the alphabet, sorry, which is 26. So 26 log 26 is constant. You could call it that. Sometimes I call it alpha, where alpha is the size of the alphabet, as I said. So because of that, the sorting on the values, there's only 26. So this creates a hash table, so that's linear time. We get all the values, which obviously is still linear time. But this only returns 26 values. So sorting 26 values, this is just going to give you 26 numbers, which you make a comparison, which is also 26. And also here, this will only contain, takes linear time and takes all of 26 space. So yeah. So what is the actual complexity of this? Well, this is going to be linear time, or O of n, n constant space, where or you could call it O of alpha space, where alpha is the number of characters in the alphabet, which is 26 in this case. And in terms of time, it'll be alpha log alpha times n, where n is the length of the character. And of course, you could do some shortcutting with the characters. But yeah, so I mostly got this. This was okay. So the key part about this problem is just try to figuring out the invariance. As I said, so my thought process is when I saw the first operation, I knew that, like I said, the positions don't matter. So I might as well sort it. It turns out not to be true for this particular example, but for similar problems, you got to sort it or put it in a collection, like a hash table, which I did. And that would work correctly because then now, when you swap two existing characters any number of times, you can always just, like it's a bag, right? Like you can always match them up as much as you want. And then two is just, basically what you're doing is you're swapping the frequency count of something, right? Basically you swap up, for example, A appears 3 times and B appears twice. So when you swap the two existing things, that's all you do, right? You swap, like A used to show up 3 times and now it shows up twice. B shows up twice and now it shows up 3 times. So you only do those swap, and because you could do that in infinite amount of times, so that only the frequency values matter, which is what my code does. And of course, combine that with operation 1, where the locations don't matter or the indexes don't matter. This is what happens. And the only tricky thing, which I got a wrong answer about, because I guess I just misread it, or I think I read it correctly, but I think I just didn't understand it correctly in my mind. Like I read it correctly, but I just didn't understand it, which was that they had to do it from existing character to another existing character. And so the way that this is true is if all the characters that are in word 1 is the same number of characters in word 2, and because if they don't, then that means that you have other characters, and the frequency maps, they may map to different characters. Otherwise, they all map kind of all together. So that's basically the idea, and that's basically what I would say. And this code is one-liner. I kind of did it to show off. We can kind of I spent a couple minutes to kind of write it up to make it a little bit more readable. So check to see if all characters that are in word 1 are in word 2 and vice versa. So if set of word 1 is not equal to set of word 2, that means that some characters that are in word 1 is not in word 2, or the other way around, so we return false. Otherwise, we build frequency map, so then we have something like, I don't know, that's to F1 for frequency 1 is equal to collections.counter word 1. F2 is the same, but for word 2. And then now we only care about the values, so maybe you could do frequency 1 value, something like that. I know the naming is terrible, but you know, I hope you're following. So this only looks at the values because we don't care about the keys, which are the characters, right? And of course, here we have at most 26 characters for obvious reason, and same as the set. And then now we just now we want to check whether the two frequency maps are the same. And you could actually do this in O of alpha times. I did it in O of alpha like alpha because it made it easier to make it a one-liner. But you could actually just have well, actually I don't know if these are sorted. So these may not be sorted. So you would have to sort them anyway. So maybe I lied a little bit. Let's do it the other way, where we sort it. So if you do it in another language, this is roughly what I would do in another language, given that some of the comparison are not the same. But then now we have like A is B or character 1 or trying to figure out what in zip of F1V, F2V. If V1 is not equal to V2, return false. Otherwise, return true. So that's basically the same code. I guess I shouldn't. I don't have to delete it. But in a maybe slightly more readable way. Basically, this is just so zip. Lines up the two frequency maps. Lines up the two frequency maps. And if we want because they're already sorted, it's basically the 2 pointers algorithm of like, okay, is the first character the same, also the first frequency the same, and so forth, and walk it. And otherwise, it returns true. And you may think that this only works if the frequency maps are the same length, which is true. But if they're not, the invariant is such that the sum of the frequencies are the same if they have the same length. So, is that true? Maybe I get a lot. Maybe this could be a little bit wrong if you're not careful. No, because because all these invariants, it should be true. But yeah, if they have different lengths, then one of the earlier numbers have to be false, or you have an extra character or something like that. So it's taken care of. It doesn't look obvious. But yeah, that's pretty much all I have. I'm curious what the hints are, so I'm going to take a look. Yeah, that's what I was saying. And yeah, okay. So that's basically the hints of what we observed, so that's kind of good. Yeah, that's all I have. I mean, I don't think you could do much faster than this, so I'm going to leave it as it is. Hit the like button, hit the subscribe button, let me know what you think, and I will see you tomorrow. Bye-bye.